This video is going to cover fractions and all four operations. So we will be adding fractions, subtracting fractions, multiplying fractions, and dividing fractions. So let's go ahead and get started, and we will begin with adding. So here we've got two sets of addition problems. Both just have fractions, no mixed numbers. So what you have to remember when you're adding or subtracting fractions, you need to get a common denominator. So we're going to look at 8 and 6 here and find the least common denominator. So then at the end, we don't have to simplify. So here, the least common denominator for between 8 and 6 would be 24. And what we have to remember is whatever we multiplied our denominator by, we have to multiply our numerator by. So here, 6 multiplied by 4 gave us 24. So we're going to do 5 multiplied by 4, which gives us 20. Over here, we did 8 multiplied by 3, so we do the same thing to our numerator, and we get 21 out of 24. So here, once we've gotten to that point, we just add our numerators. We get 41 over 24, and we would call that fraction an improper fraction, so we need to change that improper fraction into a mixed number. So in order to turn this into a mixed number, we see how many times 24 goes into 41. So here that's one time. We've got 17 left over. So our answer is 1 and 17/24. So go ahead and try that second one. Pause the video, and then once you've got your answer, check to see if you've got the same answer as me. Okay, so when we have our improper fraction, we need to change that into a mixed number. And 44 goes into 73 one time. We've got 29 left over, so it should be 1 and 29/44. So before, I got a common denominator of 44, changed our numerators as well, added the numerators, and then changed this into an improper fraction. We're going to do one more addition problem, and we are going to use a mixed number to do so. So our next slide is going to be covering that. Okay, so we have 2 1/6 plus 4 2/3. So the same rule applies here. You have to get a common denominator, but before we do that, we're going to look at our whole numbers. So we've got a 2 and a 4. For addition, you don't need to change these into improper fractions. We've got 2, we've got 4, so then we can add those up at the end. But right now, we're going to just focus on these fractions here. Common denominator would be 6. So I'm going to leave that first one the same. And then my second one, I'm going to multiply by 2, so I have to do the same thing to the numerator. So I'm going to have 4 and 4, 6. Then we're just going to add our fractions. So we're adding the numerators in each fraction, and we get 5/6. Our whole numbers, 2 and 4, would be 6. So our final answer here is 6 and 5/6. We're going to go ahead on to subtraction now. And the same rule applies in addition as it does in subtraction. You need a common denominator. So for our first one, 7 and 5, common denominator would be 35. We're going to change both of these fractions to have a denominator of 35. So to get 5 to 35, we multiply by 7. You do the same thing on the top here, on that numerator. So we would have 14/35. We multiplied 7 by 5, so we're going to do the same thing to our 6. So we should have 30 over 35. Once we've got that, we're going to look at our numerators. Instead of adding like we did in our addition problem, here we're actually going to subtract. So 30 minus 14 gives us 16. We've got 16/35 as our answer. So again, we've got another subtraction problem. I'd like for you to pause the video, try it on your own, and then we'll walk through it together. Okay, so I've changed my fractions to have a common denominator of 24. I've also changed my numerators, so now I'm left with just the subtraction part. 16 minus 9, that gives us 7 over 24. We have to see if we could cross-cancel, or not, excuse me, simplify anything. Here we can't, so 7/24 is our final answer. So we're going to go ahead on with subtraction with mixed numbers. So here again, we don't need to change these into improper fractions unless when we are subtracting our fractions, it doesn't work. So we're going to go ahead and see that. We're going to first look at just our fractions, get a common denominator of 8. We're going to leave the second one alone. Here we multiplied by 2. We've got 7 2/8. minus 4 and 5/8. So we're looking at the 2/8 minus 5/8. We can't take 2 minus 5 without getting a negative number. So this one we actually need to borrow. So we're going to take the 7, turn it into a 6. And we're going to take that one whole that we took away and put it here, making it 8 out of 8, which is just one whole. So when I add 8 to 2, that gives us a 10. So we actually have 6 and 10/8 minus 4 and 5/8. If we were to go back to this 6 and 10/8, if we simplified it, we'd get right back to 7 and 1/4. So we borrowed in fractions. So we would do 10/8 minus 5/8, which would give us 5/8. 6 minus 4 gives you 2. So we're going to move on now to multiplication. We've got 2 multiplication problems and then 2 more division problems. So here we're going to do some multiplication. For multiplying and for dividing, we do not need a common denominator. So it saves us a little bit of time. But what we do look for is if we can cross cancel with this multiplication. So if I look at 5 and 7, there's no common factor between 5 and 7 that's besides 1. We're going to leave that alone. But 2 and 8 have a common factor. I can actually divide both of these numbers by 2 and get a whole number. So 2 divided by 2 gives me 1. 8 divided by 2 gives me 4. Once I'm done with cross canceling, and I can't do anything else with that, all I do is multiply straight across. New numerator times numerator, denominator times our new denominator. So I've got 1 multiplied by 5 gives us 5. 7 multiplied by 4 gives us 28. So our final answer is 5/28. Now the second problem looks a little bit different. We have a mixed number here. And when we have mixed numbers with multiplying and dividing, we have to change this into an improper fraction. And we use that C method. So we multiply our denominator by our whole number and then add our numerator. So 4 multiplied by 2 is 8, plus 1 is 9. So our fraction is actually 9/4 multiplied by 2/3. We're going to check to see if there's any cross canceling. We can cross cancel our 2 and our 4, divide them both by 2. That 2 becomes a 1, this 4 becomes a 2. And we can actually cross cancel on the other side as well, divide them both by 3. 3 divided by 3 is 1, 9 divided by 3 is 3. We multiply straight across. Here we get 3 halves, so we'd have to make that a mixed number, which would be 1 and 1/2. And that's our final answer there. We've got 2 more problems. Both are division. Again, with our mixed numbers, we need to change these into improper fractions. We're going to do that first. 1/4 divided by 8 times 4 is 32, plus 5 is 37 over 8. That 8 does not change. Now, for division, there's one extra rule. We actually have a keep, change, flip rule. We keep the first fraction the same, change that division sign to multiplication, and flip our second fraction. So 8 over 37. We've done keep, change, flip, and we've got now a multiplication problem. Now we can look to see if we can cross cancel. And here we actually can, which is great. We're going to divide both 4 and 8 by 4. We get a 1 and 2. And we multiply straight across. And our final answer is 2 over 37. That cross canceling kind of replaces the simplifying aspect at the end of our problem, so it saves us some time. We also don't have to deal with as big of numbers as we normally would, which is nice. So we always look to see if we can cross cancel with multiplication and division. So our last problem, again, it's division, but we have 2 mixed numbers, so we have to change both of these into improper fractions. So here, 4 times 4 is 16, plus 1 is 17. 17/4 divided by 3 times 2 is 6, plus 2 is 8 over 3. So here, now that we've changed them into mixed number or improper fractions from mixed numbers, we need to do keep, change, flip. We've got 17 over 4. Change that division to multiplication, and then flip 8/3 into 3/8. We look to see now if there's any kind of cross canceling, and it looks like on this one we actually don't have any. So we're going to multiply straight across. I know 8 times 4 gives us 32, so our denominator is 32. And then we have to deal with our 17 multiplied by 3. And when we do that, we end up getting 51. Now, this is an improper fraction, so we do need to change that into a mixed number. So we need to decide how many times 32 can go into 51. We know that it can go in at least one time. And then when we take 32 away from 51, we get 19 as our leftover. So that's our numerator. 32 is our denominator. So 1 and 19/32 is our answer for division. So to kind of sum things up, addition, subtraction, you have to have that common denominator. For multiplication and division, you do not, but you want to look for any kind of cross-canceling once you've gotten it to a multiplication problem. So multiplying, we just look for cross-canceling, changing our mixed numbers into improper fractions. Division, we've got to change it into our mixed numbers into improper fractions, then do keep, change, flip, then look for our cross-canceling. So once that division problem has been turned into a multiplication, that's when we can look to cross-cancel. So feel free to review any part of this video again, rewatch any walking through the problems, and good luck studying.